Hey, hello and welcome to today's GFG problem of the day. Hope you all are doing well. Find duplicate rows in a binary matrix. So what the problem is saying is there'll be a matrix given, right, which will be a binary matrix basically, which will contain the binary elements 1 and 0. Okay. So what we want to do is we want to find out the duplicate rows. So for example, now in this case, right, there are two rows and two columns, right? So this row, the second row, is the duplicate of the first row, right? So we have to return the row numbers basically, the duplicate row numbers. Okay. So here it will be like we have to return in zero based index. Okay. For example, 0 and 1. So this the second row, that which is according to zero based indexing, it is 1. So we have to return 1. Similarly, here, right, 0, 1, 2, and 3. Right. So this 1 is duplicate. That is the second row is duplicate of the first row, and this fourth row is duplicate of the uh, third row. Right. So according to the zero based indexing, it will be 1 and 3. Right. 1 and 3. Okay. So there are a lot of ways to solve this problem, this particular problem. So one way which we are going to use is like the decimal equivalent approach. For example, right? For example, we have this as a matrix, right? This is row number 0 and this is row number 1. Okay. So this is a matrix. Okay. In simpler terms, 1, 1, 1, 1, 1, 1. Right. So now what we're going to do is we will calculate the decimal equivalent. So what we're going to do, we're going to iterate through this. For example, for int I equal to 0, or let's say j equal to 0 to this column size, right? If column size is, let's say, c, right? Okay. So j equal to 0 to c. Now we'll have one uh, variable decimal 0. Now what we're going to do is we are going to uh, how we are going to do, for example, right? So we are going to using the left shift operation. Okay, we are going to find the equivalent, the binary equivalent. For example, if this is a case, right? This row is a case, right? 1, 1, 1. So what we're going to do? So it will be like this mat of, or for example, yeah, for example, now I is this, right? And j is here, right? I is this. So mat of I j left shift by j. Okay, left shift by j. So how it will play, let's see. Okay, so now mat of I j, for example, right? I is here and j is here, right? So and what is j? J is 0, right? So mat of I j is 1, j is 0, right? So 1 left shift by 0, so it will give 1 only, right? When we say left shift by 0, for example, what is the binary equivalent of 1? For example, this is this, right? And we are saying left shift by 0, by 0 number of, by 0 number, right? So we are not moving anything to the left, right? So it will be 1 only. Okay. So decimal will contain 1 now. Decimal will contain 1 now. Okay. Decimal will contain 1. Now, next, now consider, sorry. Okay. Now consider this, yes, this element, right? Now j is 1. J is 1, right? Now, earlier j was 0, j is 1. So mat of ij. I is still the same. J has changed, right? So this element will consider now. Okay. So what is this element? It is 1 only, right? So binary representation of 1 is this. And what is j? J is 1 now. So we have to left shift by 1. Okay, we have to left shift this bit, right? The last bit by one number of times. Okay. So what it will be? 0, 0, 1, 0. When we say left shift by 1, right? So we'll move this last bit by these many places, by one place, right? By one place. So it will be this 0, 0, 1, 0. Okay. Now what is the decimal equivalent of 0, 0, 1, 0? It is 2, right? So we are going to add this to our decimal. Okay, the result. This result, right? We are going to add into decimal. So 1 plus 2 equal to 3, right? Decimal is 3 now. Okay. Now we'll come here, right? J will change to 2, right? J will change to 2. So this element will consider, right? So mat of ij, what it is 1 again. So 0, 0, 0, 1, binary representation, right? And left shift of j. J is 2 now, right? 2. So this means you have to move this last bit by 2 places to here. For example, now it will be 0, 0, 1, 0, 0, right? 0, 1, 0, 0. So what is the binary equivalent of, the decimal equivalent of 0, 1, 0, 0, right? It is 4. It is 4. So we'll add this to a decimal. So 3 plus 4 equal to 7, right? So you know, right? 1, 1, 1. This, the binary representation of 1, 1. The decimal equivalent of this binary representation 1, 1, 1 is 7 only, right? So decimal will contain 7. Now we have this, right? For this particular row. For this particular row, we have the decimal equivalent. So what we are going to do is we are going to put in the set, right? We are going to put this decimal into set. We'll have a set, right? So first we'll check whether this decimal equivalent, right, which is 7, has appeared in set or not. If it has appeared, right? If it has appeared, then we are going to, if then we are going to treat that as duplicate, right? Treat that as duplicate. Okay. So first, yeah, treat that as duplicate, and we'll put into our resultant whatever it is, array or list, right? Our resultant array. So result will so now 7 has appeared for the first time, right? Now again we'll come here I, right? And we'll check what is the decimal equivalent. It will be 7 only. So we'll check in the set. Yes, this 7 is already there. So we'll add I to our result. I is what? 1 now, right? We'll I 1 to the result. Okay. So this is the intuition. Let's see the code, right? Let's see the code. Now, if you see, this is, okay, let's first see the Java C++ code. Okay. So we have this set, unordered set. We have this result, right? Now will be, see, now this is the iteration for the rows, right? And this is the decimal number, right? And this is for the column iteration, right? So here what we are doing, I've already explained this operation. We are calculating the decimal equivalent, right, of that particular row. Okay. So now then we are checking whether this number, the decimal number, has appeared in set or not, right? So if it is appeared, we'll add. If it is already present, we'll add into I, right? We'll add into the result, right? The I, okay? And if it is not, we'll simply insert into set, okay? To check for the next row, okay? And simply then we'll return the result. So this is a C++ code, and the equivalent Java code is here. We'll have hash set, we'll have error result. This is the follow for row iteration or column iteration. This is the decimal, right? And then we are calculating the decimal equivalent, right? Okay, and then we are checking whether it is there in set or not. If it is, we'll add into the row number into the resultant array list, right? Else we'll add into the set, right? So this is a solution. Let's submit it. So yes, it is accepted. Thanks for watching. Please subscribe to my channel and like the video. Also have a happy, healthy, and a great day. Thank you so much.